Alright, you guys, for number 6, I'm going to let you guys know right away that there's a lot of context you need to get familiar with. The concepts and the math behind it are hard. Okay, number 6 is definitely a challenge. And the one friendly thing about it is that the procedure is fairly straightforward, but you gotta know what you're doing. Okay, so I'm gonna do my best, especially at the beginning, to give you a lot of context so that you understand. If you already know the context, I invite you to skip ahead until I actually start the work. See, but for now, it's a lot of blah blah, a lot of context. Here we go. And so this problem gives you two main pieces of information. It gives you what I'm putting in red, which whenever I use red, I will be working with that. And it gives you what I'm putting now in blue, right? And so what's in red is that you have that the coefficient of x to the power of 6 in this expansion that I'm putting in red, or the expansion of blah, 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 right, is 448, okay? Well, on the other hand, they also tell you in the part that is in blue that the coefficient of x to the power of 6 in this expansion, okay, in this expansion is 2,880, right? And so what's the main goal we sort of have to do here? Well, eventually you need to find the values, right, of a and b, where a and b are both greater than 0. In other words, a and b are both going to be positive. Okay, that's all it's really telling you. A and b are both positive. And so how the heck do you get a and b from here? Well, from the part that's in red, you can get one equation. From the part that's in blue, you can get another equation. Okay, but now we need to interpret how the heck do you even get an equation out of this, right? What is this even saying? What is a coefficient? What is an expansion? Blah, 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 blah. See? So first, let me give you a basic example that we can use as a common ground, right? Imagine you have, say, x plus 2 to the power of 2, okay? By now, if you're watching this video, you should be like in 11th or 12th grade, you should be a junior or senior, and so by now you should know that this does not give you x squared plus 2 squared, right? That's not exactly what it does, all right? And if you weren't sure, don't worry, it's a common mistake, everyone does it. We're all human, so chillax. This is a safe space, okay? The squared, what it does when it's outside of the parentheses is really just that the parentheses now shows up twice. All right, so first it shows up twice. All right, so this is not the step you're supposed to take. See, first it shows up twice, and now you do like the distributive part of it, right? So you distribute the x times x, so it's x squared times x times 2, which is plus 2x, plus 2 times x plus 4. And now you end up with x squared plus 4x plus 4. Okay, so that is like the sort of like step that you're supposed to take. See? If it happens to be x plus 2 to the power of 8, which is a little bit like the example that is happening in number 6, right? You would end up with x plus 2 times x plus 2 times x plus 2 times x plus 2 8 times, right? And so this step that I just did now of distributing, right? When I distributed on this step over here, and I fully ended up with this answer over there, you would have to distribute like eternally, right? I mean, not eternally, you can do it, but it takes a really long time, right? And so once you distribute, you end up with the expansion, right? So this is the expansion because think about it this way, it's like the long version, right? And so the long version is the expanded version. When it's in the parentheses, you can think about it as the short version. And so basically from here in the example that I gave you, let's answer a couple questions. See, so on the one hand, what is the coefficient? Am I writing that correctly? Coefficient. So why is it showing up red, dude? Probably just English, Spanish. Yeah, no worries. So coefficient of x squared, right? We also need to find the coefficient of x to the power of 1. And just to be mean, I'm going to also find the coefficient of the constant, all right? So in this example, the coefficient of x squared, the coefficient is always like what is next to x squared, right? The coefficient of x to the power of 1 is what is next to x to the power of 1. So for example, the coefficient of x squared, well, what is next to it? Take a good look. What is next to this x squared is just a 1 times x squared. So the coefficient of x squared is 1. The coefficient of x to the power of 1, well, here it's to the power of 1. So the coefficient of x to the power of 1 is just 4. And the coefficient of the constant, or the one that's like alone, right, it's just going to be 4 because it's this guy here, right? Technically, it can also be the coefficient of x to the power of 0 because anything to the power of 0 is just 1, right? And so it's going to be 4 times 1, basically, over there, right? All right, that was a more hardcore mathy comment. But point is, now we understand what we mean by coefficient. So coefficient is whatever's next to that specific number, see? And so clearly, if you do this distributive thing and find the expansion, eventually you end up with an x to the power of 6, right? And so it's asking, like, what is the coefficient that is right next to that? Now, you could technically, like, do it by hand, but we're not going to do that, see, because it's going to take like 14 million years to truly like solve that. And so there are faster ways to find the coefficients. There are faster ways to solve this, which I will show you now, see? But I needed to do this small introduction so that we understand what we mean by coefficient. We understand what we mean by expansion, etc., etc., see? And so technically, the coefficient of x to the power of 6 is 448. That means that somewhere I have 448 x to the power of 6. That is what it's telling me. Somewhere you have 448 being the coefficient of x to the power of 6. That's what it's telling you. And down here, it's super similar. It's just 2880 x to the power of 6. And so using this information, somehow you need to put in a and b using the formulas that I'm about to show you, and that can help you find the values of a and b. See? Now, all of that being said, let me make a little bit of space over here, okay? Then I will pull up the formulas and we're going to solve this relatively quickly, see? Because as I said, the most tedious part is understanding what it's asking for, how to use the formulas and stuff like that, see? So we're also going to spend a little bit of time understanding how the formulas work, what they're saying, what they're asking for. But once we do all that, you're going to realize, this exercise is actually kind of quick, see? But understanding concepts is definitely the hard part in the beginning, see? So let me put this in yellow again because I erased it. And now that we have space and we're all nice and happy, we go to the formula booklet, see? And actually, before anything, the formula booklet, you guys, is very important to get familiar with it, see? A lot of people get comfortable thinking, I have the formula booklet, I have the answers, like easy peasy. It's no use to have the formula booklet if you don't know what's in it, see? Or if you don't know what it says, or if you don't know what it's asking for. For example, pop quiz, see? Let's go to the sign rule, right? Sign rule has big letters and small letters. Do you guys know the difference between the big letters and the small letters? Do you guys know when to use the sign rule? These are all important questions, okay? You can't just get comfortable thinking, I have the sign rule XD. Nah, dude, you gotta know what it does, all right? In order to cook, you need the ingredients. These are your ingredients. You gotta know what's in your kitchen, you know? So let's get cooking the right way. And by the way, if you have a question, what is sine rule? I do have a video on it, but just very quickly, technically in a triangle, you have like big letters, which are your angles, okay? And you have the little letters, which are the sides associated to those angles. So that would be little, that would be little b, this would be little c, okay? So that is why there are big letters and small letters in this whole section. The little letters are sides, the big letters are angles. All right, so that was just a quick pop quiz. You use sine rule, cosine rule a lot, but what good is it if you don't know what it has, what it says? And so, in the formal booklet, you should recognize, right, just visually, that there is a section for these type of exercises. If you ever face anything like this that has an expansion or asks for coefficients and this or that or blah blah blah, you should be thinking, I've got two formulas here that can really help. The first one, and this is all under binomial theorem, okay? The first one is the one up top, see? Of course. And the second one is the one on the bottom. Now let's take a second to absorb like what this is telling us. See? On the one hand, the one up top, you have a plus b to the power of n equals this whole thing. See? And all this is really telling you is that with any a plus b to the power of n, so it can be I don't know, for example, what I showed earlier, x plus 2 to the power of 2, right? So x plus 2 to the power of 2, in this context, you would say that a is x, that b is 2, and that n is 2. And so if you plug all of this over here, right, you were you will also end up with what I had earlier, right, which was the x squared plus 4x plus 4. You're going to reach that. See? If you plug this into that, you're going to reach this here, literally, okay? So it's a sort of like shortcut, okay? Think about it that way. It's a sort of shortcut to get the final answer, the whole thing, right? Now, why is it also useful? You're going to realize, sorry, realize, you're going to realize that there are a lot of different terms here, see? So take a moment, and I'm going to highlight all the plus signs, see? Okay, that's not a good for highlighting. I'm going to take a moment and highlight all the plus signs, okay? So between all of these plus signs are all the different terms, much how you have a bunch of plus signs here, okay? And so having that in mind, if they're asking just for the coefficient of x to the power of 6, you got to identify where you have x to the power of 6 in here, see? Now, my like original sort of function is this guy here, right? So let me write that here for a second. You have ax to the power of 3 plus b, all of this to the power of 8, right? And so if you're looking only for x to the power of 6, well, take a good look. See? Where is x? X is right here. To what power is x? X is to the power of 3. And so technically, if you want to reach an x to the power of 6, right, you have to be very careful with how all these different exponents are behaving, because you need to reach basically x to the power of 6, right? And so on the one hand, you have that. See, so you want to be careful that you reach x to the power of 6, and you're very aware of how n and r relate to each other. Now, what is r doing? All that r is really doing is like it's playing with the exponents so that you decrease, right, one by one each time, right? And so depending on the r that you choose, you land a certain coefficient, all right? So if you want to land the coefficient of x to the power of 6, well, you gotta take a moment and realize, okay, so if you have ax to the power of 3, that means you already have a to the power of 3 sort of like going around, see? And so in this context, you can evaluate that n, and I'm putting it in red because it's the first step that I'm doing, right? So n is gonna be 10, is gonna be 8. Sorry, n is gonna be 8 because it's what is on the exponent here, right? And the r that you're gonna choose is the r that you want to choose in order to reach an x to the power of 6. Now, because you have ax to the power of 3, and if you wanted to reach a 6, then that means you need to have this squared. And so the moment that you have this squared, or you have a 2 going around up here, right, it means that you distribute both. You end up with a squared times x to the power of 6. And so basically what I'm trying to tell you is that r has to equal 2, so that you plug in a 2 on the outside. The 2 affects the 3, you end up with the 6. Okay? So that small step is very, very relevant, right? And so the term that you're going for is where n equals 8 and r equals 2, right? Now, you're still probably thinking, all right, I get that, see, that you're going for an x to the power of 6, so n is 8, r is 2, so that when you distribute, you end up with to the power of 6. Like, we all agree with that, so it makes sense, right? It makes sense, it's fair. But you're probably still a little bit confused with what is this big C, right? And so all of these that I'm now putting in purple talk about this big C, right? And this in of itself, right, has to do with the coefficient. So now we're talking business, right? So all of these are the coefficient. That is also why it says C for coefficient, right? Now you have a big N right next to it. You have an R like a sub R or something like that. Okay, this is not C to the power of N or C to the power of R or anything weird like that. This is just a way that mathematicians put it so that we know that, oh, this coefficient, we're plugging in this N and we're plugging in this R. For example, if you put C of, in this example, right, C8 and R2, that means, it's a coefficient that has an n equals 8 and an r equals 2, right? And why is that relevant? Because the moment you plug in over here, if you follow that, right, if you follow that n is 8 and that r is 2, then if you plug it into this equation, you end up with 8 factorial, I'll talk about what that is in a second, divided by 2 factorial, parentheses 8 minus 2 factorial. See? And also, because you're going for the sixth term, okay, that means that the a and the b next to it also behave with the same n and r. So you're going to have times, right, times a to the power of 8 minus 2 times b to the power of 2. All right? So that was a lot of blah blah. Let me make a quick sort of like summary of like what just happened. See? So on the one hand, we plugged in the formula on the bottom, which is this guy here. See? So if you plug in this guy here, this is just for finding the coefficient next to x to the power of 6, right? Because this is telling that you're going for the coefficient of x to the power of 6, right? So this is the coefficient of x to the power of 6, is that whole thing right there, right? But because you want to also find how the a and the b are like related to this, see, if you specifically want to find the coefficient of x to the power of 6, well, that is also next to, think about it this way, that is also next to and a and a b respectively. And so you, on the one hand, you like if you plug this in, right, you're gonna have the c8 and the 2, so the coefficient of x to the power of 6, and also an a to the power of 8 minus 2 and a b to the power of 2, right? And so if you plug all of this in, thinking in the coefficient of x to the power of 6, right, you're going to end up with this times a to the power of 6 times b to the power of 2. Now you just found what this is from the formula on the bottom, right? And so you end up with 8 factorial divided by 2 factorial times 6 factorial, right? Times a to the power of 6 times b squared. And all of this is going to be equal to 448, all right? So that is the context of the problem. That is what's going on, see? So this last couple steps and jumps and concepts are a little bit tough. I hope it was clear. The hardest jump I think that you have to do is realizing that if you're going for x to the power of 6, you need to also consider the a that is next to it and the b that is next to it, see? So I think the main thing you can focus on is specifically like defining what is n, defining what is r, and thinking of filling in like this spot here, see? And if you want to fill in this spot here, well, to fill in what I'm putting now in pink, you have to use the formula down here, right? And for filling in the other two, it's just filling in what is n and what is r into a and b, respectively. See? So, following that idea, this equals 448, right? So let me put that over here. You have 8 exclamation mark, which is, it's not that exciting. I'm not sure why they put an exclamation mark, but still. So 8 exclamation mark, which is 8 factorial, divided by 2 factorial times 6 factorial times a to the power of 6 times b to the power of 2. And all of this equals 448 because all of this is a coefficient of x to the power of 6. See? All right. What is factorial? How does it work? So, a factorial is this thing in math that it multiplies like in a descending order. See? So let me make a couple examples and by then you're probably going to get it. See? So, for example, whatever. So 2 factorial, okay, is going to be 2 times 1. 3 factorial is going to be 3 times 2 times 1. 4 factorial is going to be 4 times 3 times 2 times 1. And 5 factorial is going to be 5 times 4 times 3 times 2 times 1. See? And so that is what the factorial is doing. It's just like multiplying until you reach 1, only with the whole numbers, right? Yeah, with whole numbers. See? Natural numbers, whatever. And so from here, well, you can just plug this into your calculator, to be honest. See? If you want to get like more hardcore, there is a relatively faster way. I guess I'll show both. See, so if you want to do it by hand, you can say that up top you have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 2 times 1. That is a 2 factorial. And now the 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, right? And so all this up top is the 8 factorial. This is the 6 factorial. And this is the 2 factorial, right? All of this is being multiplied by a to the power of 6 times b to the power of 2 equals 448. And so if you write it out like this, it's much more apparent that, so this can go away with this. Boom, 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 boom. All right, interesting. And also over here, this 8 is technically 4 times 2. So you can also go boom, boom, right? So up top, all you really end up with is 4 times 7 times a to the power of 6 times b squared equals 448. So in other words, you have 28 a to the power of 6 times b squared equals 448, right? And so that is what the factorial is doing. That is how you solve it. If you want to use the calculator, you can. See? So what you can also do is plug this into your calculator, and let me show you quickly how. So in your calculator, first, I suggest you put a fraction. So you can use alpha y equals, put a fraction up here, the first one, and then you can press 8, because it's an 8. We all agree that it's an 8. And then you can press math, because this is a very mathy thing to do, right? So you press math, you go to probability, the probability column, scroll down, press the fourth one. It's a factorial symbol. So 8 factorial times 2, times 2 factorial times 6 factorial, right? Following over here, the 6. Boom, 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 boom. Press enter. You get that 28, the same 28 I got down here. See? So I showed you how to solve it by hand. You can also plug it into your calculator. There's a bunch of different ways. The last hint I'm going to show you is that technically this step here, you could have left it as 8 times 7 times 6 factorial, right? Because it's like the rest of it. Here you have 2 factorial times 6 factorial. And you can have this go away with this. See? That can happen. You can set it up like that. Like go in descending order of 8 factorial until you reach 6 factorial and have them go away with each other. See? That also works. You just end up with 8 times 7 divided by 2. See? So you're going to get the same answer, right? I promise you. These are just a bunch of different approaches for the same thing. And the last step over here that I'm putting in red, you want to get a and b alone, right? And so you divide by 28 to both sides. What do you end up with? You end up with a to the power of 6 times b squared equals, let's find out. So 448 divided by 28 equals 16, right? So this looks a little bit more friendly. But from here, if I ask you, okay, so what's a? You can't get a alone, right? Because the moment you try to get a alone by, say, dividing by b squared, so you end up with a to the power of 6 equals 16 divided by b squared, well, you can't really solve it because you have a b going around, right? And so here's a very important concept that I need to lay out for you right now. You have how many variables? You have 2 variables, okay? You have the variable a and you have the variable b. And so for now, you need another equation. So until you have another equation, you can really try to solve this, right? Point is, right now you have one equation, 2 variables, can't solve. The moment we have 2 equations and 2 variables, we can solve, all right? So keep that in mind. You need another equation, and where do you get your other equation? Well, duh, the other piece of information that is in blue, see? So now that we understood the context, what coefficient, what expansion, what all of that stuff means, plugging in the part in blue is probably going to be a lot faster, see? So we go back to the formula booklet, and the procedure is awfully similar, right? And so now it's a little bit different because now we have the same thing, but it's to the power of 10, right? And you're still going for an x to the power of 6, right? You're still going for an x to the power of 6. So in that sense, it's kind of friendly, see? But now you need to redefine n, you need to redefine r. So in this context, n, of course, has to be to the power of 10. I mean, sorry, n is 10 because you have a to the power of 10, right? And r is actually a little bit different, right? So remember how earlier I told you that we chose that r had to be 2. so that you would do ax to the power of 3 and ended up with a 6 over here. So r again has to be 2, right? And this is very important to point out because it's a very common mistake. A lot of people here would say that n is 10 and that r is 4 because that way you end up with 6 because of 10 minus 4, right? And what's truly relevant here is that the exponent ends up being 6. And so if the exponent ends up being 6, in this context you have an ax to the power of 3. And the only way to make the exponent reach an x to the power of 6 is making the 3 times 2 on the exponent. So that is why r has to equal 2 in this example as well. So the approach is pretty much the same, just that instead of n equals 8, you now have an n equals 10. R still has to equal 2 in order to reach the x to the power of 6. Okay, so all of that being said, you're plugging it in thinking that n equals 10 and r equals 2. So let me write down the equation. Let me sort of like do it from 0 or whatever, see? Just so that we're all on the same page and we do the procedure again, because procedure, as long as you learn them well, you're going to do well on the IB, see? I think a lot of IB math is just understanding procedures. So let's roll through it one more time, right? And so for what I have in blue, my main tool is that any coefficient is going to be n factorial divided by r factorial, right? Times n minus r factorial, see? And here I'm saying that n is 10 and r is 2, so that we reach the exponent of x to the power of 6, right? Now, for that specific term, right, on the one hand, you have NCR, and now I'm thinking in what I have and what I'm putting now in purple, see? So to reach this, right, go ahead and write it out, see? So you have NCR, and then you have A to the power of N minus R, and then B to the power of R, right? So if you follow this specific step, or like you try to get that specific term, all you really need to do is be consistent with n is 10, r is 2, and everything's going to flow. See? So if you plug in n is 10 and r is 2 from here, that means you end up with an n of 10, c, and r of 2. Your a is going to be 10 to the minus 2 times b to the power of 2, right? And so this right here, right, is just going to end up being, you're going to plug in over here, right? You're going to plug into that formula. So n is 10, so it's 10 factorial divided by 2 factorial times 10 minus 2 factorial times a to the power of 8 times b squared. And so this is what's going to equal 2,880. All right? That is the procedure. Now it should have been a lot more clear given all the context that we talked about. See? So I need to like solve this part. See? And so whatever, I'm just going to go ahead and use the formula. I'm going to go ahead and use the calculator is what I mean. Sorry, mixing words a little bit. Put in the fraction first. So alpha y equals, press the first one, and now just do everything. So 10 math, the fourth one, divided by 2 math, the fourth one again, for the factorial thing, times 10 minus 2, and the factorial again. See? So here I'm showing you like plugging it in from 0. It's still going to work. Trust the process. The factorial of this is 45. So basically you end up with 45 a to the power of 8 times b squared equals 2,880, right? Now, if you want to finish getting a and b alone, you can divide by 45 to both sides. This goes away with this. You end up with a to the power of 8 times b squared equals, so 2,880 divided by 45, 64. So this equals 64, see? And once again, I'm going to quickly put in green that here you have two variables, right? Now, what I told you earlier is that if you have one equation with two variables, you can't solve. But now we're in the situation where we have two equations with two variables, so we can solve. Guys, anytime you have like more than one equation and more than one variable, you enter the world of systems of equations. Now, in systems of equations, right, your two main tools, and this should ring a bell or two, right, is elimination and substitution, right? Substitution. Now, because A and B are multiplying each other, I feel like substitution is a lot more like friendly, intuitive, and all that stuff. See? And so what I can do is that, and I suggest the same approach always, right? Take a moment and define one equation as your first and one equation as your second. And so here, if I take my first, right? If I take my first, I end up with, and I get B alone in my first. Okay, so I'm going to be trying substitution, right? So if I take the first one, I can end up with B squared equals 16 divided by A to the power of 6, right? And so this, I'm going to call my first one with an asterisk, all right? And guys, this is not like how you're supposed to solve it or whatever. This is just the procedure that I suggest, right? And so the moment you put that, you have the first one in asterisk, it's a kind of reminder that, yo, this is your first equation, but you switched something around. Okay, that's why I'm putting the asterisk. So if you take like what you have from the first one switched around a little bit and you plug it into the second one, right? That is unchanged, right? And so this is the big step that I suggest. Change one of them, plug it into the other one. That is substitution, quite literally. Now, what do you end up with? Well, in the second one, you have a to the power of 8, and you have b squared, but b squared is now this. So you have a to the power of 8 times 16 divided by a to the power of 6 equals 64. And ladies and gentlemen, let's just all be honest here for a second, because this is a safe space. I'm just this guy on the internet that is talking about math, okay? You usually shouldn't trust guys on the internet, but for math, or for this channel at least, I suggest that you do, okay? This, let's all agree just for a moment that this looks nasty. This looks terrible. Like, who would want to solve this? Like, let's be honest. You literally have an a to the power of 8. You literally have an a to the power of 6. Things are being divided. Things are being multiplied. Things are fighting with each other, dude. It's crazy, right? It's wild out here. It's wild. But notice something. This step that you just did is massive, right? And I know I'm a little bit of a math nerd, but notice this. Earlier, our issue was that we had two variables, a and b, a and b. And this right here, although it looks nasty, how many variables do you have? You have just one. And I know you might be thinking, oh, but isn't there more than one a? And I say, yeah, sure, there's more than one a, but you have only a's. And so now, kapow, now you can reach a equals like an actual number. Before you would reach a equals something something b, now it's only a equals something something, like an actual number. You see what I mean? So trust the process. The magic of system of equations is that you go from two variables to just one. That is the whole idea of this whole process in the first place, okay? So from here, you can try to get a alone. And much how I mentioned earlier with how the exponents work and stuff, this technically is going to be 8 a's up top. So it's a times 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 a divided by times 16, right? Divided by a times a times a times a times a times a. So that is 6 a's. Up top you have 8 a's. All of this equals 64. And so technically you can have this goes away with this goes away with this, boom, 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 ba, 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 ba. That happens. See? So you end up with 16 a squared equals 64. Divide by 16, divide by 16. So a squared has to equal 4. And so from here, oh, well, you look at that. I think you guys know how to do this. So from here, you can do the square root in order to get rid of the squared, of course. So this goes away with this. You end up with a equals square root of 4 is just 2. Now, because you did square root of 4, that means it's plus or minus 2, right? Why would it be plus or minus 2? Whenever you do square root of 4 and you put 2, what you're actually asking is which number multiplied by itself gives you 4. But technically, 2 times 2 gives you 4. 2 times negative 2 gives you negative 4. Negative 2 times 2 also gives negative 4. But what does negative 2 times negative 2 give? Ah, it gives positive 4. And so here you need to consider wherever the symbols are the same. So either positive 2 or two negatives being multiplied, right? So that is why you leave it as a equals plus or minus 2. So let me just leave that up here. a equals plus or minus 2, right? That is what we have discovered thus far. And so if you know that a equals plus or minus 2, you remember that they told you, careful, a and b is positive. So boom, that helps you even more. A, you have to leave it as a equals 2. And now that you know that a equals 2, finding the value of b is very easy because you can plug it in pretty much like anywhere. See? So if you go ahead and plug it in, I don't know, like here, you can solve it. See, if you plug it in here, you can also solve it. All these different things like are going to work. See? So I'm just going to plug it into the first one up here. I think it's more straightforward, whatever, who cares? So a equals 2, right? So you end up with 2 to the power of 6 times b squared equals 16, right? And so notice, I know it's very straightforward, but again, you have only one variable, right? And so the beauty about system of equations is that once you get one of them, you just plug it in into one of your equations, either of the original ones. Okay, careful, either of the original, and you only have one variable, you only have b, so you're going to reach b equals something, right? Anyways, you have 2 to the power of 6 times b squared equals 16. So from here, well, what is 2 to the power of 6? Thankfully, we can ask our good old friend graphing calculator, and he's going to tell us it's 64. So 64 times b squared equals 16. So from here, what you can do is that you can divide by 64 in order to get b squared alone. And I know this looks kind of crazy, but trust the process. B squared equals 1 over 4. And so if you do the square root of this, because you have to in order to get b alone, this goes away with this, you end up with b equals plus or minus 1 divided by 2. Right, 1 divided by 2, right? But because you know that b has to be positive, so b equals plus or minus 1 divided by 2, b has to equal 2, okay? How did I get this? Well, technically you can just do square root of 1 divided by 4. It's going to give you 0.5, which is 1/2. See? Now, I recognize I might have gone a little bit fast here, so let me show you quickly. Technically, this last step, I showed you that you have b equals square root of 1 over 4, right? And so, just a quick sort of square roots thing that you can do. If things are only being multiplied, right? You don't have a plus 3 in here, you don't have anything like that going on. If things are only being multiplied or divided, like the 1 and the 4, you can rewrite this as square root of 1 divided by square root of 4. So square root of 1 is just 1, and on the bottom it's going to be 2, right? So that is how I did the quick sort of skip that b equals square root of 1 over 4 is just plus or minus 1/2. Technically, there's a step in between that I should have showed you earlier. I show you now. If things are only being multiplied or divided, you can rewrite the square roots only on top and only on the bottom. It makes it a lot easier to handle. Anyways, enough blah blah. The final answer is that a has to be 2 and b is not 2. I don't know why I put that. Sorry. B is 1/2 positive. See? And so that is how you solve number 6. I think it's really hard. I'm just going to give my honest opinion. A lot of times, you guys know I have like these positive vibes on my channel and etc. and blah blah blah. But I gotta let you guys know number 6 is hard. Okay? And one of the things that I find hard about number 6, and just so you keep it in mind, is that it's very, very specific. Okay? And this is also why I insist so much on the formula booklet. If you don't know about this formula, right? If you don't know about how these two equations relate with each other, right, for finding the constants, and if you don't know what they mean by coefficient and what they mean by expansion and all this different stuff, you're just not gonna get these 7 marks, right? But now that you know how this works, you're gonna realize, all right, it's actually not that crazy, it's not that hard, but you do have to know what this is even saying in the first place, okay? So there's a lot of stuff in your in your formula booklet, and in the IB that they can ask you that, to my sort of perspective, is just really specific, man. It's just crazy specific, and you gotta be aware of the specific things that they can ask for. This type of exercise is definitely under that realm of things that you have to watch out for. It's very specific. Might as well invest some time like learning it. And given that you watched this video, you did. So congrats. I hope it helped. And yeah, what other specific things should you like really watch out for? Well, what comes to mind quickly is the sine rule has an area of a triangle formula, So be careful with that, okay? And you also have the trapezoidal rule. I've noticed trapezoidal. Does trapezoidal rule not appear here? It's crazy. Maybe it's only AISL. I would be mistaken to tell you. Well, the other very specific thing is the discriminant. See, for number of solutions. Also very specific. Also shows up in this paper too. So it's just that kind of, or paper one, I think. It's just that kind of stuff that you need to be aware of. That it's awfully specific. That it can show up for you. Apparently, you don't have trapezoidal rule here, so never mind. Sorry for the bamboozle. But point is, enough blah blah. I don't want to make this video any longer. There's really specific stuff out there that you just gotta be aware of. Be on the alert for this. See, if you don't know about these formulas, if you don't know how they behave, you cannot solve this problem. See, there are some things that you just need to know in order to start the problem. See, don't miss out on 7 marks, dude. If you know a little bit about this, you can get like 4. If you know it well, you get 7. Okay, it's that type of exercise. But if you don't study it at all, it's a certified 0. There are other things that if you know it a little bit, you can at least get a couple points, right? But this is so specific that if you don't know it well, you get 0 points. Okay, that's my point. So specific, you get 0 points if you don't know it. If you know a little bit, you already get 3 or 4. If you know it well, you get 7. See? So, invest your time properly, do the right thing. That was a very long conclusion. But there it is. I hope it helped. See? So, I'll see you around. Hope it helped. Much love. And at least for me, happy Monday. I'll see you around. Take it easy.